So this is the review for the quiz next class on 10.1c through D. I really want you guys to do well, so watch this video, make sure you can do all the problems on here. First things first, notice this, vocab, 6 points. So 6 out of these 7 will be fill in the blank vocab, okay? Open-ended, 14 points, so that's a total of 20 points. First off, a central angle measures 26 degrees in a circle of radius 10. These two things are going to be important, so I'm circling them. Give the length of the intercepted arc. This right here is length, this formula. Okay, so I want to use that formula. S equals, R is radius. The radius is 10. Okay, and then theta. Well, theta, if you remember from your vocab, like for arc length, angular speed, or sector, you need to put theta in radians. Right now, it is in degree. So, something else that's good to know. Pi over 180 is how we convert, right? So, 26 degrees over 1 times pi over 180 degrees. Simplify that. That is 13 pi over 90. Okay, multiply that out. Well, you can see if you want the 9 and the 10, or the 90 and the 10 cancel. So I still am left with 13 pi over 9 centimeters. Or if you did it in your calculator, it was about 4.4 centimeters. That's my final answer. In the next one, they want area. This is area formula. So area equals 1/2. R again is 10. Theta, oh, that's going to swear it, sorry. Theta is still the 13 pi over 9. Okay, multiply all that out. You should get, if you leave it in terms of pi, 65 pi over 9 centimeters squared, which is the same as about 22.69 centimeters squared. Okay, so there is length of an arc and area of a sector. The next question is they want to know the linear velocity. That's this formula here, linear velocity. So V equals, R still stands for radius. The radius is still 10. Okay? Omega, that W-looking thing, instead of degrees or like the angle measure, it is your revolutions, but it's in radians. Again, just like theta's in radians here, omega's in radians. So to convert 40 RPMs, which means revolutions per minute, you need to know this other one's conversion factor up top here, 2 pi over 1 revolution. The reason is because 1 revolution means 1 time around the circle, and 1 time around the circle is 2 pi radians, also 360 degrees, but we want it in radians. So to get omega, I go ahead and do, what was it, 40 RPMs? So I'll just say 40 rev for now over 1 times 2 pi over 1 rev. Your revolutions cancel, so that's just 80 pi. Okay? 10 times 80 is 800. So 800 pi, and this is centimeters per minute. If you prefer to multiply it out as a decimal, I think it was, what, 2513.27 centimeters per minute. I won't be picky on which way I want it on the quiz, so as long as you can do it one way, that's fine. All right, the next one, these word problems for these towns, right? Now remember, I'm always going to give you this, but the radius of the Earth is 3,960 miles. That's what your book told us. So there's a town, and it lies at 51.3 degrees north. So 51.3 degrees north, okay? There's another town that's at 33.8 degrees north. They want me to give the distance between the two cities. So that's this distance right here. That's also my arc length, which is also the equation S and then R times theta, right? What is R? 3960. What is theta? Well, it's whatever this degree is, the difference of those, but in radians. So first you have to find the difference. 51.3 minus 33.8. And that's what, 17.5? That's still in degree. Convert that. So 17.5 degrees. The conversion is 180 over, or pi over 180 in this case. So then my theta is 17.5 pi over 180. Do that in your calculator, all in one step. I got, if I did it correctly, 12.9.51 miles. So 1,290 miles between those two random cities. On the next page here, they want us to give the equivalent angle, that's going to be between 0 and 360, because remember our circle is only 0 to 360, and then tell which quadrant it's in. So remember, the way our quadrants are named, it's like a C for coordinate plane. So starting here, it's 1, 2, 3, and 4. Okay, so a C. 510 degrees, that's going to be more than one time around the circle. So to figure out, you're going to go 1 and sum to figure out what that sum is. You do 510 minus 360, and you just get 150 degrees. Okay, 13 pi over 3. Now, if you prefer degrees, you could go ahead and, oh, sorry, I didn't say what quadrant that's in. That would be quadrant 1, right? Nope, quadrant 2. I don't know why I did that. Okay, on to number 5. You can convert this to degrees if you want, or you can just leave it in radians, and rather than subtracting 360 degrees, you could just subtract 2 pi. Okay, and you can do that on your calculator. 13 divided by 3 minus 2, and then do a little math fraction on it. I got 7 pi over 3. The problem is that's still more than one time around the circle, so you got to subtract 2 pi one more time, and now you get pi over 3. So this is really the same as saying 1/3. So if you're between, 0 is here, 1/2 pi is here, pi is here, So 1/3 is going to be between 0 and pi over 2, right? So that's actually your first quadrant. Okay? If we move on to number 6, this is also one from our notes. We have the point 7, 24. 7 is my x, 24 is my y. So I go to the right 7 and up 24, right? Draw my terminal side. This is my initial side. This is my triangle now. So in the x direction, I went 7 to the right. In the y direction, I went 24 to the, I was going to say north, but up. Now you need to find this hypotenuse here, right? To get that, you use the Pythagorean theorem. So 7 squared plus 24 squared equals c squared. 7 squared plus 24 squared is 625. And then you want just c, so square root both sides, and you get just 25. So this hypotenuse is 25. Remember, you're always standing at the origin. So that's your theta. So sine theta is going to be opposite over hypotenuse. The side opposite of theta is 24. The hypotenuse is 25. Cosine is adjacent over hypotenuse. So 7 over 25. Tan is opposite over adjacent. Okay? Pause it and redo it if you need to. Lastly, we want to use reference angles. The reason we have to use reference angles is because 240 degrees is not, we don't know what that is. It's some decimal, right? So we can draw it on my coordinate plane. If I'm starting at 0, this is 90, 180, 270. So if I'm starting here at my initial side and I'm going 240 degrees, that puts me somewhere in here for my terminal side, okay? So I kind of have to decide though, well, if this is 180 and this is right here and this is 240, what is the distance between those? Because that's this angle right here. And it's actually, what is it, 60? So I've got myself here a 30, 60, 90 triangle. Now, I drew the third side of my triangle as I was talking. Remember that third side always goes from your x-axis to your terminal side, okay? But anyways, now we've got ourselves a 30, 60, 90 triangle. You need to have it memorized. Across from the 30, which is over here, is always x. Across from the 60, which is here, in this case, is always x root 3. Across from the 90 is always 2x, okay? So the first one, sine 240. Start by doing this. Put sine 240 into your calculator. You get negative 0.8660254,038, right? That's not going to help us. I need to have the exact ratio, hence in the directions. But it will help me when I want to check my answer. So sine is opposite over hypotenuse, right? Now that I have, and it's always of this angle that you're standing at, so opposite of angle 60 is x root 3. Hypotenuse is 2x. Your x's cancel, so you're just left with x root 3. Root 3 over 2. But you may be asking yourself, well, how come when I did it in my calculator, it's negative? Because remember, even though this is a triangle right now, this side, this side is really negative, right? Because it's your y, and your y is going down, okay? So could you have done that in the beginning? Yeah, sure, you could have done that. So I'm going to put a negative here with it. So then my final answer, negative root 3 over 2. All right, and maybe I just double check. I put in my calculator, negative square root 3 divided by 2. Okay, I get the same answer I did when I put this original one in my calculator. All right, let's go through and do cosine 240. Cosine is adjacent, so adjacent to 60 is x over hypotenuse, which again is 2x. Those cancel, what am I left with? Just 1 over 2. Okay, again, check it in your calculator. Cosine 240, you get negative 1/2. Wait a minute, why is it negative? So then I look back at my triangle and I say, oh yeah, because x is going to the left of 0, which means that side, that adjacent side, is really negative x. So I go back and I say, I put that into my picture. Okay, you could put all that in the beginning if you want as well. We'll get the same thing. All right, last but not least, cotan 240. Well, cotan is actually the flip of tan. So rather than opposite over adjacent, we're going to do adjacent, which we now know is negative x, over opposite, which we know is negative x root 3. My negative x and negative x cancel, but I still have an issue. I can't have root 3 on the bottom. So you multiply top and bottom, and you get root 3 over 3. When I'm putting that in my calculator, there is no cotan button. You must do 1 divided by tan 240. And you get 0.57735, something, something. So then I say, well, is that the same answer as root 3 over 3? And it is. So we know we've done it correctly. If you can do everything on this review, you will be fine on the quiz next class, but you must keep practicing. Good luck.